Hello everyone and welcome in this tutorial about Now motions. The Now, the manufacturer of the Now, made available a couple of different types of motions that you could call. And there is also an option in the SIG framework to create your own motions for the Now robot. These tutorials can be found in the SIG applications code under demos Now motion for the available motions and motion recorder for creating your own motions. Let's have a look at the motion demo first. The only thing that you have to provide is the IP address of the robot, and you need to have Redis running, so I will start it right now, and then you're good to go. Let's have a look at the code. So there are different types of motions or ways to look at the robot's positioning and locomotion. One is postures, so that's getting the robot into a certain posture. There are a number of available ones here. We see crouch, lying back, lying belly, sit, some variations of sit. In practice you will need stand, sit and crouch, and maybe lying back or lying belly, depending on the needs of your interaction. And you just fill in the name here in this Now posture request and the speed between 0 point something and 1. Let's have a look also at the documentation of the manufacturer itself. There are for postures here and for animations there, where you can actually also see how those postures look like. Going back, we also have an animation request where you provide a path like this to an animation. And of course, you need to know which animations are available, and that's something you can find on the manufacturer's website as well. There is a whole list of here that you can try out. And it's just as easy as that. So in this particular animation, it's not only that the robot will move, but also that its eyes will change color. So you can have a look at the LEDs demo to understand more about how to manipulate the LEDs. But it's good practice to make sure that your robot always resets back to the default at the end of your interaction, so that when you start a new interaction, it's fresh. So in this case, this is how you would reset the Now LEDs back to the default white eyes. And as always, make sure that at the end of every interaction, you give the robot a break and put it back into the rest mode. This way you would prevent the motors of the joints to overheat and reduce the wear and tear of the robot, so that we can enjoy the Now robot for a couple of more years, hopefully. It actually always needs to be in an active position in order to move. In this case, posture requests will actually make sure that the robot goes to an active posture. But for example, an animation request, if the robot is not standing, in this case, in the active mode, it will not move. So you need to make sure that, for example, with a wake up request, that the robot is actually standing in the position you want it to be before you can start an animation. All right, let's have a look at what this code actually does. So the robot is now in the default crouching position. It will actually stand up, and it will now do the waving animation that's part of this Hey animation. And if you notice that the eyes have turned green, and now with this request they've been set back to white, and the robot is going into the rest mode. All right, cool. And if you're a Windows user, you will probably see this error. Hopefully we can fix this in a future update, but for now it doesn't break anything. It's just at the exiting is still not completely free of this bug. Let's look at the motion recording. So we need to set a couple of more things here. Apart from the IP address and Redis running, we need to provide a motion recording demo. We need to have a file name where the motion recording will actually be saved to. In this case, motion recording demo. So the motion you will record on the robot by actually physically holding the joints you want to manipulate and manipulating them yourselves by moving them. It will be saved into a file on your machine. And how long this recording needs to be in seconds. So this is a 10-second recording. This will create a motion file that will record basically all the joint angles. It's in a certain time interval, in a certain frequency, and it will replay the motion you created yourself as closely as possible. Here you can set which joints you want to manipulate. On the website you can find the descriptives for each joint, what the labels are, and you can add them to this chain if you want to manipulate more. Be mindful when you're creating your own motion with the limitations of the robot, so don't force it further than it can be. What's important too is that it will now only record the joints, angles, etc. of these two, in this case the left and the right arm. Everything else will not be included in this motion file, so it will actually, when played back, it will actually play it back from its current position. So it will only move the arms in whatever position it was. So ideally you would record something and then go to the same base posture. For example, if you're having a standing recording, first make sure that the robot is standing in the base posture before recording and also before playing. Technically you could play this motion too when the robot is sitting, but given that the robot is closer to the ground, for example, if you have a very low arm movements, it might actually hit the ground then. So if you want to record, if you want the robot to do a motion when it's sitting, make sure that it's sitting when you're recording it, so that you always know that the robot is making safe motions. So with that warning set, let's have a look at the run code. In this case, this is the wake up requests. I want the robot to be standing and active, but I want this to set this. I need to set the stiffness of the joints that I will manipulate to 0. So you can never move the joints of a robot when it's active, and it will actually, you feel a lot of resistance. Do not force it, because then you will break the robot. So this makes sure that the joints will manipulate. In this case, the left and right arm, the stiffness is set to 0, so that we can actually move them ourselves when the recording is activated. So this activates the recording, start recording, only the joints that we've selected for a particular time. And once this time is over, you send the stop recording request. And I have one recommendation here. If you're wanting to do some motion recordings with end users, be a bit more communicative about when the recording is starting, and especially also when it's stopping, so that you don't startle the end users when you set the stiffness again to, in this case, 0.7. But also for yourself, it might be a useful addition to include some text-to-speech from the robot here, that it's verbally saying when it's starting the recording, notifying you, and also maybe do a countdown to let yourself or an end user know when it's about to stop. And then the recording is saved to your disk. We can actually retrieve it here as well. And in order for it to play, we need to set the stiffness up again. And then we set a recording here. And then after the recording is finished, or after the replay is finished, we will make the robot go back to its resting position again. So let's have a look at how this works. So the robot is standing up if it wasn't already. And then you can actually move it around. And then it will try to play this motion as precisely as you've just created it. And then it will go to the rest mode again. So have fun with this. Be mindful of the limitations of the robot. Try it out. Do not force anything, and create beautiful animations for your interaction. All right. Good luck.